Hello students and welcome to the next video on fundamental of business statistics. In this video basically we are going to study what frequency distribution is. This concept is very important and we will be frequently using this concept as we move forward, calculating mean, median, mode, standard deviation and other measures, okay, in statistics. So let's see what frequency distribution is. Frequency distribution is defined as the list of all values obtained in the data and their corresponding frequencies. So to understand it in detail, let us basically go through an example. So we have example data for 10 families owning number of vehicles. So basically this is the data. So there are 10 families. So first family owns one vehicle, second family owns two vehicles, third family owns one vehicle again, so on and so forth. And we are expected to now populate this particular table. Okay, we are expected to find out what is the frequency distribution for this data of 10 families. So let us see how we should progress. There is something called as the tally marks. Okay, so to calculate frequency distribution, we should use this particular tally marks column. Okay, so let's move on. So what is the first data, right? Data point. First family has got one vehicle. So there are number of vehicles which we had laid down in rows. So we have one as the minimum number of vehicles that is found in the data, and we have 5 which is maximum number of vehicles that is found in data. So data comprises of all the numbers between 1 and 5, including 1 and 5. So when we come across 1 in the first data point, we just draw a vertical line, okay, here against 1. Then we draw a vertical line against 2 because our second data point is 2. We add one more vertical line against ones because our third data point is 1. Okay, we have fourth data point as 4, so one more vertical line here. We have fifth data point as 2, so one more vertical line against 2. We have sixth data point as 3, so I'm going to add one vertical line against 3. We have seventh as 4, so one more vertical line against 4. 1, so one more line against 1. Ninth is 2, so one more line against 2. And last is 5, so I have one line, vertical line against 5. Now what do I do? I just count the number of vertical lines. So this is 3, 3, 1, 2, and 1. So how do I read this data? So I say I have 3 families in the data who have one car. I have another 3 families in the data who have 2 cars each. I have one family having just 3 cars. I have 2 families having 4 cars and one family having 5 cars. So this is my frequency distribution of data, and total number of family, if you total this, it will come out to be 10. 3 plus 3, 6 plus 1, 7, 9, and 10. The above frequency distribution can be termed as discrete frequency distribution, ungrouped or discrete frequency distribution. Now, why this is discrete? This is discrete because number of vehicles which we have are whole numbers, so it is discrete, right? And ungrouped because there is no group in this, it is a single number that we have put. Okay, so this frequency distribution is ungrouped or discrete frequency distribution. Let's move on. Let's see another example, and this example is for grouped frequency distribution. Okay, so let us take another example. We have salaries of 50 employees, and these salaries are ranging from 10,000 to 50,000. So there are almost 50, and basically to do it faster, I have just ensured that I sort this um, basically salaries in data so that I can quickly count. Okay, so when we have groups, we have one more important column in between, and that's mid values. So one has to find out what is a mid value of a group. So this is 15K, this is 25K, this is 35K, and this is 45K. And what is the frequency distribution? So of course this will fall in the first band. So 1, 2, 3, 4, 5, 6, all falling in the first band. 7, 8, 9, 10, 11, 12, 13, 14, 15. So first 15 fall in first band. Then I have 20,500 onwards till, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 employees having salaries between 20 to 30K. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 employees between 30 to 40K, and I have 5 employees between 40 to 50K. So that's my 50 employees, and this is my frequency distribution, and it is for grouped, it is for group frequency distribution, and you understand what's the meaning of grouped. The previous one we saw was discrete, this one is grouped, right? Let's move on. So basically there are two type of classes in grouped frequency distribution. What are these two type of classes? Inclusive type and exclusive type. Both in, let's see what first inclusive type is. So both lower and upper class limits are included in the class. In the inclusive type class, just see that in a class, say for example, 10 to 19 is my first class, 20 to 29 is my second class, then both the limits, upper and lower limits, are included in this class, right? And the most important thing to note is there is a gap between lower limit of next class and upper limit of previous class. Okay, so this is what you should look at in the inclusive type. And inclusive type is suitable for discrete variables. So discrete variables are whole numbers, number of cars, number of students is what we have seen, right? The second one grouped class. Second type of class is exclusive class. Upper class limit is excluded from the class and included in the next class. So here you will find 10.5 to 19.5, 19.5 to 29.5. So here 19.5 is not included in this particular class, but 19.5 is included in the next class. Now, most importantly, there is no gap. There is no gap. There is an overlap. There is no gap. Okay. The lower, the upper band of previous class is same as lower band of next class, right? This is ideal for continuous variables, right? Like weight, wages. What are continuous variables? Those are real numbers having fractions. There are no gaps between the successive classes. So two types of classes in group frequency distribution: inclusive type and exclusive type. Next, moving on to next. Very, very interesting. Sometimes you come across a situation where a continuous variable is given in an inclusive type class, and hence in that case, you have to first convert it into exclusive type. We have seen if it's an inclusive, it has to be discrete. But a continuous variable, a variable which is supposed to be expressed in decimal point, is given in in inclusive type class. In that case, you have to convert it to exclusive. So why this particular is an inclusive type? There are two ways to notice. One is there is a gap. Yeah, so there is a gap in inclusive type. There is a gap, right? So 19 and 20, 29 and 30. Now I have to convert it to exclusive type. So how do I convert it to exclusive type? Suppose these variables needs to be expressed in decimal point, okay, or these variables are in decimal point, and my classes given are inclusive type. I need to convert it into exclusive type. I will find out what is a gap. So 20 minus 19 is equal to 1. So 1 is the gap. So I will divide this 1 by 2. That gives me 0.5. So what I do is I deduct 0.5 from the lower band, and I add zero point 0.5 to the upper band. So my new class, which is the exclusive class, will be 9.5 to 19.5. And the same thing I will do here. So this will become 19.5 to 29.5, and this will become 29.5 to 39.5. And this is how I convert my inclusive type classes to exclusive type classes. And immediately you can make it, there is no gap, right? There is no gap here. See, no gap. 29.5, 29.5 here. Okay, and this is how I convert my inclusive type class to exclusive type class. Okay, sometimes you come across a situation where you have open-ended classes, and open-ended classes, so lowermost class would be termed as less than 10, and highermost class would be termed as more than 50. This is an example. Okay, so this is an open-ended class, this is an open-ended class, right? So what is the mid value of these classes? Middle classes, so this is 15, this is 25. Even for lower ended class, which is open ended class, or the first class, which is lower open ended class, 5 becomes my mid value, and here 35 is my mid value. Okay, so this is how I calculate the mid values for my open ended class as well. Okay, so with this, we come to an end of frequency distribution video. Thanks for watching, and we'll have new video coming soon. Thank you.